Hi everyone, welcome to part 3 of question 1, NECO Physics Practical 2023. So in this video, I'll be showing you a possible question that you can also get. And this follows up from what we've been doing with the question 1. We've already made 2 videos on what to expect from question 1. Now in this video, as usual, I'm going to perform the experiment, then I'll also teach you how to do the manipulation. So I'll try as much as possible if I can fit everything into this one video so that we can get to know how you manipulate and also carry out the experiment. At the end of this video, I'm going to, if there's enough time, I'm going to manipulate the result and then use the manipulated result to plot the graph. Okay, let's get started without much ado. The question is similar to what we have in the previous video, but there's a little difference. So let's read. You have been provided with a method stand, clamp and post, a set of masses, a spiral spring and stopwatch, split cup and other necessary apparatus. Using the diagram above as a guide, carry out the following instruction. Here you can see that on this guide there is a meter rule. So the meter rule is to determine the position of the pointer when it is unloaded and when it is loaded. So let's see. Suspend the spiral spring vertically as shown in the diagram. We have done that. Suspend the mass hanger on the free end of the spiral spring. Note the position of the pointer and record it as N0. So it means that you're going to have N0 and we're going to record that. Okay, so we're going to take the measurement on that. Then add a mass M equals 50 grams to the hanger. Note the new position of the pointer and read and record it as L1. So we have a new position. So we're going to have a new position where we are going to record L1. So let me draw a table for this. I'm going to have my table. We have so we have M measured in grams. Then on the left column, we're going to have L measured in cm. Okay, I won't be including this here because this is just going to be a one-off. We just take that measurement one-off. Then we are also asked to determine T for 20 complete oscillation. Okay, so we're going to put T in seconds. We're going to put in seconds, then we are going to evaluate T. Okay, that's also going to, T is going to be small t divided by 20 in seconds. Okay, then we are going to evaluate T squared, that means seconds squared. Then we have to also evaluate E is equal to L minus L naught. So we are going to have E. Okay, this will be in cm also. So this is my composite table. So the next thing I have to do now is to carry out the experiment. I'll carry out the experiment, then I'll also do the manipulation. So let us take a look at the setup for the experiment. Then we'll come back and carry out the manipulation for this. Okay, here this is a table for my arrangement. Again, I have here, instead I have L, I have T1, T2, because I have to take the average. Remember I said that when taking the time period for this, it may be very slow, so it may hamper your rate. So you have to take it twice, and you take the average before you look for the period. Now again, after this, so these are my slotted masses I'm going to use. What I just did is a 50 grams and a set of 20 grams. I just add them together and carry out the experiment. Now in the experiment we have to mark L0. So this is my M naught here, and I can read it off here. Maybe you may not be able to see. This is my pointer here. This is my pointer. You may not be able to see it clearly, but I can read it off here. So I'm reading it downward this way. So my F naught is 54.6.7.8. So my M naught is 54.8 centimeters. So I've noted that. Now the next thing I have to do is to put the first mass, which is 50 gram mass. So I put the 50 gram mass, determine the new length. So I think I have to readjust this. So let me readjust it so that I can be able to get the new length. So this time around, the new length is at, okay, this is 55.5.6.7.8. So 55.8. So I'm going to record that here. 55.8. So that's why I have the record that there. So I now have to set into 20 oscillation using my stop clock. So this is my stop clock as usual. So I'm going to set this into 20 oscillation. Let's set that into 20 oscillation. Let's set this into small oscillation. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So my time is 10.1, 2, 3, 4, 5, 10.5 seconds. So my T1 is 10.5 seconds. And I'll do it for the second time again. Okay, let me just set it again. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So my time is 10.2 seconds. So I have 10.2 seconds, which is closed. So the next thing I have to do is to add another mass to make it 7. So I'm going to stop it here. Then this is just to show you how to carry out the experiment. So add another mass. This time around, I'll determine the new length again. So let me determine the new length. So the new length is exactly on 57.0. So this is 57.0. So now I have to set into oscillation again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So my time recorded is 11.5. Okay, take that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this time around I have 11.2, which is close. So I'm going to end this here and show you how to manipulate the reading. So we can determine E from here. We can determine T by adding this and this together, divide it by 2, you get this. Add this and this together, divide it by 2 to get T here also. Now to evaluate E is going to be L minus 54.8. So now this is the value of E. Okay, now it's time for us to do the manipulation. Now, if you have not, I have done a video on how to manipulate the values for t squared in my previous video, so you can search for those videos under this the comment section of this video. But here I will devise another means to find the values of t, big T, and big T squared, and also find how to get L and E from our manipulation. This is what I'm going to do. I'm going to let me fill the masses inside this place, and we'll continue with that. So these are the masses. So we have to get L. The formula we're going to use to get L, we know that from most of elasticity, L is equal to K E. So from here, E is going to be equal to F over K. Okay, so for these masses, we assume that we are using a mass angle of 10 grams. So we're going to use a mass angle of 10 grams. So it means that this mass, where we're going to be working with for this mass is going to be 60, this will be 80, 90, 100 grams, 120 grams, and 140 grams. So the next thing I have to do is this. So I'm going to convert all these masses plus the added mass 10 grams to kilogram by dividing by 1000. So how do I go by that? So I'm going to have this plus this, it's going to be 60. 60 divided by 1000 is going to be 0.06. So let me pause this so that in order for us to save time, I'll divide all of that and put the values on the board. So these are the masses converted to kilograms. So they are now in kilograms. So the masses are in kilograms. Now remember that I added this 10 to all of these to make them 50, 60, 80, 100, 120, 140, then divided by 1000 to obtain these values here. So the next thing I have to do is to multiply this number by the value of acceleration due to gravity to convert it to what? Newton. So here I'm going to use the value of acceleration due to gravity as G equals to 9.8 meters per second. So that's what I'm using, per second squared. Okay. So I'm going to multiply all this by 9.8 to arrive at their weights here, their forces. Okay. So let me just run that out. So these are the weights. The masses have been converted to weight by multiplying by 9.8 meters per second squared. You can actually use the value for G to be 10 meters per second squared. So that will be fine. Okay. So the next thing I have to do is to get the values of E. Now, my value for K is equal to 9.17. Okay, if you do not understand how I arrive at the value of K, you also have to check my comment section. There's a video I've done on how I arrive at my K. So it will be necessary for me to do that here again. So you can check through that video to get the value for K. Okay, so let's get our E now. So our E are going to be these forces here divided by 9.17. So for the first one, E1 is going to be, so let me get the values of E here. So E1 is going to be the force 0.588 divided by 9.17. So I'm going to multiply this by 1000. Why? Because I want to convert the value of E back to centimeters. So wherever I have here, I'll just multiply it by 100. So I'm going to multiply by 100 to get back to centimeters. So my E will be in centimeters. So I'll just work that out. So this is going to be equal to, let me work that, 0.588 divided by 9.17. Is equal to, okay, so I'll multiply that by 100 also. So that gave me 6.4. I'll just take that to one decimal. I have 6.4122. So I'll take it to one decimal to that 6.4. Then take it. And now the beauty of it is that I will not have to press all of this on my calculator again. Write it on the board. You don't have to do, just divide this by this and then multiply by 1000, and then I fill the result here. So this for the first part. So for the first part, this is 6.4. So I'm going to put it here. So I'm going to pause the video and get the values of E for the others. Okay, so these are my values for E. Now there's a beauty of this. If you check this, you see that the difference between this and this and this and this and all of the difference between the consecutive number is just between 2.1 and 2.2. These are just the differences between them. So these are the differences between them. So this is what you can do. You see that since you know that the differences between this and this is just, you just get the difference and just walk over it. You can just use that to multiply instead of going back to be multiplying and dividing by all of this. So you can work that, and so if you check the differences, it's just between this and this, over and around that. Okay. Now to get you see, this is where I'm starting from. To get now this is what you are going to do. You're going to fix any value for L naught by yourself. You're going to choose any value for L naught for yourself. So let's say my L naught is, let's say 20.0 cm. So that's my L naught. If my L naught is 20.0 cm, then what I need to do, you know that L naught is E is equal to L minus L naught. It therefore means that I'll just have to add E to L naught to get what? L. So what I'll do, I'll add this to this, 20 plus 6.4, that will give me 26.4. So obviously this is going to be 28.5. So let me pause the video. Okay. Now this is the beauty of this. So you see what I've done now? I just added all of this to this. Now the beauty of this is that you can choose any value for. So students in the same hall can apply this method, and these values here will be entirely different. This and your K value can be also different. You can choose any value of K that ranges from 9 to 10, depending on what you want to do. Okay. So I said you should look at the comment section. You get the video on how I arrive at K and how you can choose your K. Okay, so let's move on. Next, we have to look for T. So we have to look for T, then look for big T and T squared. Do I have that on the other video that you are about to watch on the comment section? I will have to use another method to derive this also from here. Okay, now when we be required to determine T, it's just the mass that we have here. That's all we need. We need the mass here and the value of K. Okay, now we know that the period of a stress string is given as this. T is equal to 2 pi square root of n over K. Here, I'm going to replace 20 with n, which is the number of oscillation. Should the exam not be 20 oscillation? Okay, so I'm going to write this as T is equal to small t all over n. So I have small t all over n is equal to 2 pi square root of n all over square root of k. Okay, if I move this n forward, I'm going to have so I'm going to have t is equal to 2 pi square root of n, square root 2 pi n square root of n divided by square root of k, and my k is 9.17. So we are using k again here. Now we know what n is. N is 20. So since we know what n is, therefore we know what pi is. Pi is 3.14. So we just repeat all of this into this. I'm going to have t equal to, now I'm going to press my calculator. I'm just going to do 2 times pi 3.14, that's what I use for pi, times n is 20, divided by square root of 9.17. So that's going to give me 41.48. The square root of n. Okay, so when we just do this, to pick any of this value, just put this value, put it here, take the square root and multiply it by 41.48. That's going to give you the value of what? See, so I'll do for the first one, then pause the video and do the other. So I'm going to have 41.48 times square root of 0.06. That's going to give me 10.16. So here I'm going to have 10.16. Okay, so let me pause the video and do it for all others. You can practice this on your own so that you master how to do it. Okay, so these are my recorded values for t. So I can get t as big T by dividing by what? 20. So this time in the other video we're going to watch on this comment section, I did the value, I did this first and I worked this back, but this time I'm working it forward, which is going to give you exactly the same note. So I'm going to do 10.16 divided by 20 to give me that 0.508. So for this, that is 0.508. So I'm going to pause the video and work all of this out. Okay, so these are my recorded values. So to get t squared, so we have to square all of this. I think that would be pretty easy. So for the first one, I'm going to get 0.5508 squared. That's equal to, so I'll just take this to 3 significant figures. I'm going to have 0.258. Okay, so again, I'll pause this and fill all of the other ones. Okay, so these are my recorded value for t squared. Okay, now in my previous videos, I did plot the graph of t squared against n in grams, but for this particular case, I'm going to plot the graph of t squared against extension. So this time I'm going to be t squared against extension. I think that's going to be very easy. So I'm going to plot the graph in a short while. So these are the values we have to plot. These values here, we have to plot the t squared on the vertical axis against e on the horizontal axis. Now the most important thing for you to do is to know how to choose this thing. In my previous video, I decided to write these numbers in powers of 10. But this time I want to use another method to plot this graph, to write these values out. And you see what I'm going to do. Now if you look at it, the smallest value should be less than 0.2, while the greatest value is 0.6. That can be pushed up to 0.7. Because it is important to know how to plot your graph. So this is what I'm going to do. So if I'm going to start from here, my graph is going to be pretty easy. So let me do this. Let me draw my vertical axis here. Okay. Okay. So I can start my horizontal axis. But before I do that, let me see if my values can fit into this space. Let's see. If I start this at 0, and I go 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. Okay, so the list is 0.6, so we can move it to 0.7, and the graph looks a little bit short, so we can push it up to 0.8. So therefore means that I can actually start my graph from this point. Okay, so that is how you first of all plan how you draw your graph. Okay, so let me do this. Okay, so let me complete my values. So we're starting both graphs from the origin. So this is 0, 0. So this is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8. Okay, I think that would be enough. So this graph is big enough. So let's go to this other add. So we have 6.4 to 15, and we want to start it from the origin. So let's see if we go 2, 4, 6, 8, 10, 12, 14, 16. That will be perfect. That will be enough. So that will be very, very much enough. So I'll just go with 2, 4, 8, 6, 8, 10, 12, 14, 16. Okay, so I can write on this side t squared in seconds squared. Okay, then on this side it's e in centimeter. Okay, so we have that e in centimeter, t squared in second squared. So the next thing we have to do is to plot the point. Now to plot the point, this is an easy way to get the point. Okay, in fact this graph is easy, straightforward, because each of these lines, it means that each of these lines is going to be 0.0. How do I get that? 0.1 divided by 10, that gives me 0.01. Okay, then for this I'll do 2 divided by 10, that will be 0.2. So each of these smaller lines on this is 0.2, because this occupies 2 units, 2 cm, and this occupies 0.1 second squared. Okay, so we can go with this. Now to plot, now you look at these values here. It may be very tedious for you to plot this value here. So this is what I'm going to do. You can easily plot these points out, but for this, because of the decimal point that we have here, so this is what I'm going to do. I'm going to get a scale factor on the t squared. My scale factor is 0.01, because each of this smaller line is 0.1. What did I do? 0.1 divided by 10, that gives me 0.0. That's my scale factor. So if I want to plot, say, 0.258 against 6.4, I can easily read this up here. This is 6, 6.2, 6.4. Okay, so 6.4 is at this point here. So I want to trace this upward. How do I do that? I'll just take my calculator, and on my calculator I'm going to do 0.258. So I'm going to press 0.258. Then I'll divide it by 0.01 divided by 0.01. That gave me 25.8. So it means that from this point, I'm going to go 25.8 places upward. So this is 10, this is 20, this is 21, 22, 23, 24, 25. 25.8 is closer to 26. So I'll just use my discretion. I'll put a dot here and I'll circle it. Let's plot 0.345 against 8.5. So let me get my 8.5. This is 8, 8.2, 8.5. So 8.5 will be in between 8.4 and 8.6. Okay, so it will be at the middle of this point here. So now let me trace that up. So I'm going to write 0.345, 0.345. I'll divide it by 0.01. So that's going to give me 34.5. So from here, I'm going 34.5 places upward. So this is 10, 20, 30, 31, 32, 33, 34. 34.5 is at the midpoint here. So put the dot here. And you draw a circle like this. It's taking shape. Okay, so let's go to the next one. 10.7 and 0.4. So let's go for 10.7. So this is 10, 10.2, 10.4, 10.6. 10.7 will be between 10.7, 8, 10.6 and 10.8. Okay, so now let's get this one upward. So I'm going to do 0.430 divided by 0.01. So that gave me 43. So I'm moving 43 places upward from here. You have 10, 20, 30, 40, 41, 42, 43. So I'm going to now 7 is. Okay? Now you try 0.8. This is where 1, 2, 1, 4, 1, 6, 1, 2. So this is how easy to calculate. That is 95, 15, 175, 171. That's fine. I'm going to 1 forward from here. This is 10, 20, 30, 40, 50, 51, 51, 51, okay, that is one. Draw it like this, okay? Now, if this table comes to you, can add them to pay, comment section, say, and that, and so that's the power of what is okay? Now, the division of 14 as 1, 2, 3, 4, 5. Now, the answer is so let's read 6.602 divided by 0.01. That is 60.2. So, now, this is forward. This is 1, 2, 3, 4, 5. This is 1, 10. So, this is 40 points. So, 60 forward. 10, 20, 30, 40, 50, and 60. So, let's have to draw the line of person. And because I manipulated my result, you see that all of them fit into a straight line. There are no deviation from the line. So, you draw this. Do not attempt to draw it from the origin, okay? So you draw from here and join them together. You can pass through any of the points, okay? So from what I'm doing here, I can draw this way, okay? I like to touch any part of the circle and to any length. Now to take the slope, this is my slope. I'll pick any point. On this, I like to draw a very large triangle and pick a very big point. On this, I will just use the 0 and this marker. That's the easiest thing I can do. So I'm going to take this point and trace it down to the x-axis. So that's my triangle that I'm going to use. So I'm going to read this point off. In fact, from this page, just count this point. Then this is 10, 20, 30, 40, 50, 60, 61, 62, 63. So I have 63. Then I'll now multiply by 0.01, okay? When you multiply this by 0.01, this is going to give you 0.63. So that's my top part. So my slope S is going to be 0.63 minus, because I drew this to the x-axis, this becomes 0 minus 0 divided by, so let's get the y, okay, let's get the horizontal part of it. So this is 16. Now remember I drew to the x-axis. Now this I'm drawing to the x-axis because this actually touches this. If it doesn't touch it, please do not draw it to the x-axis. You can just draw it to this point and draw it through this point and read off this point here. And also read off this point. Okay? Minus 0. So this is going to give me 0.63. The unit of this is second square divided by 16 cm. So I'll just divide that. So now it will give me 0.63 divided by 16. That's equal to 0.039, let's say 4 seconds square per centimeter. Okay? Now you may be asked to evaluate anything. Maybe you may be asked to evaluate k is equal to 4 pi squared all over slope or thereabouts. Okay, you may be asked to do that. So that should give us, to evaluate this, I'm going to have 4 times 3.14 squared divided by 0.0394. Okay, 4 times 3.14 squared divided by 0.0394. So that gave me something close to 1000.9. Okay, I was divided by this, so that's cm per second square. Okay, so that should be the meaning. Now, use the graph of t square against extension. It's possible because you know that f is equal to ke, and if you take this, because f is proportional to e, then therefore means that e can also produce the same effect as the mass of the object. Since g is constant, you can say the mass of the object is proportional to what? E. Okay, so it therefore means that instead of plotting t square against m, you can also plot t square against what? E, because e
is proportional to what? N. And in the materials they asked to provide, they also included that you should put a a pointer. Now, for you to put a pointer means that you have to take positions. And if you are taking position, then it therefore means that it is possible for you to for them to ask to look for what? The extension. So I have dealt with all of this extensively, and I'm sure that if you are lucky enough to watch these 3 videos, there's nothing for you to fear about when it comes to question 1 in physics work practical. So on to the next one will be question 2, then we'll move on to question 3. So for question 2, we'll do the graph, the practical, also do the manipulation also. Okay, until then, see you. Do not forget to do the right thing, subscribe, make your comment, share and like this video, because this video could be of help to everybody that wants to write NECO. Thank you. God bless you.